Hey guys, it's Mr. Dugell, and today we're going to evaluate which side is greater using algebra tiles. There are times when I'm able to determine if a side is greater, and there are times when I just do not have enough information to tell which side is greater. So we're going to start by using our rules to cancel out algebra tiles. I'm going to focus first on the left side, and I know that if I have the same color tile on the front and bottom, they cancel out, so I'm going to do that with these tiles. I'm left with two X's in the positive end. I can also do that with my unit tiles, so I'm going to go ahead and cancel these two. I'm left with two negative tiles up front and a positive tile in the negative section. I know that I can move this to negative if I bring it into the positive section. So I am left with 2x minus 3 on the left side. On the right side, when I look at my x tiles, I have two of the same color in the positive. These do not cancel because they are the same color. When I go to cancel unit tiles below, these two will cancel and these two will cancel. I'm left with 2x and then a positive tile and a negative tile. These tiles, according to my rules, do cancel because this is 1 minus 1. And I'm just left with simply 2x on the right side. So if I go to evaluate if it's greater than, less than, or equal to, I need to first notice that I have the same amount of x tiles. I have 2x in either case. On the left side, I'm given negative 3. On the right side, I don't have any units. So if I choose a negative number, let's just choose negative 100. My left side is going to be 2 times negative 100 minus 3. My right side is going to be 2 times negative 100. So here I have negative 200 minus 3, which equals negative 203, and on the right side I just have that negative 200. And when I go to evaluate which is greater between negative 200 and negative 203, it is better to owe someone $200 than owing them $300. The right side is greater. If I now change that to a positive 100, we have 2 times 100, which is 200, minus 3, which equals 197. On the right side, I'm left with 2 times 100, which is 200. 200 is greater than 197. Again, the right side is greater. And if I choose a neutral number, which our only neutral number is 0, I would find, if I put 0 as what's being multiplied for x in both the left and the right, I would find that 2 times 0 is 0, minus 3 is negative 3. Compared to the right side, which is just 2 times 0, which is 0. It's better to have $0 than owe someone $3. The right side, again, is greater. So no matter what, the right side of my equation is greater than my left side. What's important to note is if I have the same amount of x tiles, then whichever unit tiles remain, in this case it's negative 3 compared to 0, whichever unit tiles are greater, that side is greater. If I have a different amount of x's, and we'll get into this in more detail later on, then I don't know which side is greater, regardless of the unit tiles. So again, if my number of x tiles are different, I don't know which side is greater, regardless of the unit tiles. That's a good introductory level learning for evaluating which side is greater. Thanks so much for watching. Hopefully this helps us moving forward.